Welcome to Excel Victory Academy, where math is made easy. Today we'll be looking at calculus, and we have 3 questions here. We have to find the dy dx of a, y equal to 2x raised to power 4 plus 3. The second question, b, is y equal to 1 over x squared plus 3x. Then c, we have y equal to open bracket 1 plus x raised to power 4 close bracket raised to the power of 3. Now what is differentiation? Because we are asked to find dy dx, that's to differentiate those functions. Differentiation has to do with a change in one parameter with respect to another parameter or variable. For instance, if we have y equal to a function f of x, if we are asked to find the change of y with respect to x, y is a parameter of variable, x is another parameter of variable. If we are asked to find dy dx, that's the change of y with respect to x written as dy dx, that's change in y with respect to change in x, it will be the derivative of, that is f prime of x, right? So for a given function like y equal to x raised to power n, there are different methods in differentiating functions. So one of them, we have the general method, otherwise known as power rule. We have chain rule, we have quotient rule, we have implicit differentiation, etc. So for power rule, if we have y equal to x raised to the power of n, the derivative of that function dy dx, we are going to be multiplying the power here by the base, that is n times x, and then we'll subtract 1 from the power, which is n here. If we are using number, if y is equal to x raised to the power of 4, what we are saying is the dy dx will be equal to, the power here will multiply the base, that's 4 times x, giving us 4x, and we'll subtract 1 from the power, that's going to be 4 minus 1, so that dy dx will be equal to 4x raised to the power of 3. So that's how to differentiate a function. We can be asked to differentiate a function, but it depends on you knowing the right method to use. For instance, when you look at the equations given to us here, question A and B, we're going to be using the power rule, otherwise known as the general method, while question C, we will be using chain rule in addressing it. So again, I just use y and x here. We can use m to represent those parameters. For instance, if m equal to the function of t, right? The change in m with respect to t will be written as dm dt, and that will be equal to f prime, that's the derivative of t. So any alphabet, any variable that is used, it follows the same principle. Now let's go back to our question. Question A, we have to find dy dx if y is equal to 2x raised to power 4 plus 3. Question A, if y is equal to 2x raised to the power of 4 plus 3, our dy dx will be equal to, remember we said you have to multiply the power by the coefficient and then subtract 1 from the power. That is we are going to have 4 multiplying 2 to give us 8. We write the parameter x, raise it to the power of 4 minus 1, plus the derivative of a constant is equal to 0. So we are going to have plus 0 here. The reason why the derivative of a constant is 0 is because it's assumed that 3 is a coefficient of x raised to the power of 0. That is 3x raised to the power of 0. And from indices, we know that any number raised to the power of 0 is equal to 1, right? So if x raised to the power of 0 is equal to 1, and differentiating this, right, it is that 1 multiplying 3 that give us this 3. So if we are to differentiate 3x raised to power 0, remember, according to general method or power rule, we are to multiply the power by the coefficient, then subtract 1 from the power, of which 0 multiplying 3, everything here will turn 0. That's why simply in differentiating a constant, we equate it to 0, right? Differentiating a constant, the answer is 0. So dy dx in this case now equal to 8x raised to the power of 3. As simple as that. So 8x raised to the power of 3 is the answer to the first question here, y equal to 2x raised to power 4 plus 3. Now let's look at the b part of the equation. For b, we have y equal to 1 over x squared plus 3x. Now, there is something we need to understand here. When you look at 1 over x squared, in indices, we can as well write this 1 over x squared as x raised to the power of minus 2. That's fractional law in indices. So in order for us to have this particular function expressed linearly, we can have y equal to x raised to power minus 2 plus 3x. Now that we have it in this form, our dy dx is equal to, remember, we have to multiply the power by the coefficient of the variable. The coefficient of this variable here is 1. So minus 2 times 1 will give us minus 2. We have minus 2. Bring the variable and we'll raise it to the power of 2 minus 1. This minus 2 is the initial power. Then this minus 1 is the one we are supposed to subtract in each case when using the power rule to differentiate a function. Then lastly, we have, next we are going to have minus 2 x raised to the power of minus 3. Minus 2 minus 1 is equal to minus 3. Next, we have plus 3x raised to the power of 0. 1 minus 1 is 0. And anything raised to power 0 according to indices is 1. So that 1 multiplying 3 will give us 3. So that our final answer will now be minus 2x raised to the power of minus 3 plus 3. We can rewrite this in another form by changing this negative index back to fractional index, such that we have minus 2 over x raised to the power of 3, right? Then we have plus 3. For question C, we have y equal to 1 plus x raised to the power of 4 in bracket raised to the power of 3. For this particular one, instead of us multiplying 1 plus x raised to power 4 by 1 plus x raised to power 4 in 3 different places, right? we are going to use chain rule in solving this. Question C, if y is equal to 1 plus x raised to the power of 4 raised to power 3 dy dx will be equal to, remember the coefficient here is 1, so 3 will multiply that 1, so that we have 3 into 1 plus x raised to the power of 4. Then the power here we have 3 minus 1, right? So using chain rule, we are going to find the derivative of this, the content of this bracket, and multiply it with whatever we have here. Note that the derivative of 1, which is a constant here, is equal to 0. So the derivative of x raised to the power of 4 is equal to 4x raised to power 3. That is, if you are finding the du now, that is looking at the content of the bracket only, we have 1 plus x raised to the power of 4. So finding the derivative of this, the derivative of 1 is equal to 0. So we have x raised to the power of 4, and x raised to the power of 4 is simply 4x raised to the power of 4 minus 1, which is 4x raised to the power of 3, right? So with this, dy dx now will be equal to 3 into 1 plus x raised to the power of 4 raised to the power 2. Then we'll multiply this by the derivative of the content of this bracket, which we found to be 4x raised to the power of 3. Right? So the next thing is for us to multiply this. Multiplying this, we are going to have 3 times 4x raised to power 3, giving us 12x raised to the power of 3, multiplying 1 plus x raised to the power of 4. Now we have power 2 outside. So this becomes the answer for the C part of this question that says if y is equal to 1 plus x raised to the power of 4, close bracket, raised to the power of 3, find dy dx. So the dy dx of this is equal to 12x raised to power 3, bracket open, 1 plus x raised to power 4, bracket close, raised to the power of 2. So this is how to differentiate a function using chain rule. First of all, get to differentiate by multiplying the power here by the coefficient of the function, subtract 1 from the power. Now, also using chain rule, you have to find the derivative of the content of the bracket, of which the derivative of 1 is 0, and the derivative of x raised to the power of 4 is equal to 4x raised to the power of 3. When we multiply it by what we have here, we are going to have 12x raised to the power 3, bracket open, 1 plus x raised to the power 4, bracket close, raised to the power of 2. This another equation. Calculate the derivative f prime of x if f of x is equal to 4x raised to the power of 4 plus 3x minus 1. This we are going to use the general method or the power rule. So if f of x is equal to 4x raised to power 4 plus 3x minus 1, f prime of x, that's the derivative of x, will be equal to 4 will multiply 4, that is 4 times 4x raised to the power of 4 minus 1 plus the power of 1 here, the power of x here is 1, so 1 times 3, we still have 3 3x raised to the power of 1 minus 1, and the derivative of 1 is 0. That's the derivative of a constant is equal to 0. So this is equal to 4 times 4, we have 16. We have 16x. 4 minus 1, we have 3. Plus 1 minus 1 here is 0. X raised to the power of 0 is 1. 1 times 3, we have 3. So the derivative of the function here is equal to 16 x raised to the power 3 plus 3. Lastly, if we have a function f of x equal to 3x raised to the power of 5 plus 4x raised to the power of 2. Find f prime of x, that's the derivative of that function x. And of course, this is going to be 5 multiplying 3, that is the coefficient of x. Then we subtract 1 from 5, that is 5 multiplying 3, x raised to the power of 5 minus 1. Plus the same thing here, 2 will multiply the coefficient of x here, that's 2 times 4. 2 times 4 times x raised to the power of 2 minus 1. And that will be equal to 5 times 3, we have 15. Then we have our x raised to the power of 4. 5 minus 1 is 4. Plus 2 times 4, we have 8. That's 8x. 2 minus 1, we have 1. So we have 8x. So this is the derivative of x if f of x is equal to 3x to the power of 5 plus 4x to the power of 2. Thank you.